Yeah. So now we have to do in today's class. The first is we have measured the measures of dispersion by a two-step method. In first, we have calculated the mean, median, mode, whatever it if it is about mean or median or mode. So first we have calculated that thing, and then we are calculating in this way. First, the difference is x minus x bar, then x minus x bar. If it is a mean deviation, we have to take the mod. If it is a standard deviation, we have to take its square, and then we have to analyze the data. So that is a two-step process in which we are like first we are calculating the center density, then we are delivering the message of like how we can calculate the standard deviation. But in case if it is about mean, if it is in case about mean, then we can have this one step process also that we are will be discussing today. In that one step process, you have to apply the directly the formula, and you need not to calculate the central density as a separate case. So what will we do that it is in a one step formula itself, we can find out the standard deviation, but this only case is applicable in case we want to find the standard deviation about mean. In case if we want to find the standard deviation about your like median or about mode, then you have to adapt the same original case which we have discussed in the previous class. But now in this particular case we can do it if and in case about mean only, then we can solve it by the this formula also. So that is the alternate method to this, but with the need not to solve in the two steps, central density separate and the dispersion separate. So in case if you apply this formula, which we will be discussing now, you can in the one step only you can calculate the value of standard deviation. Fine. So we'll take the example. So let's suppose this will be the example can be like 5 to 10. So this will be your data series. So the data series will be like so the data series maybe it's like this one 5 to 10, then you have maybe 10 to 15, 15 to 20, then you have maybe 20 to 25 and 25 to 30 and 30 to 35. Suppose this will be your time intervals, you can say classes, and this is the frequency you want to calculate the standard deviation of this data. Fine. So first of all, we have to, as it is a continuous data, we have to check those two conditions if they are satisfied or not. So these two conditions are satisfied each of five, and classes are of equal size also and inclusive in nature. So both are satisfied in this. Now next is now next step is you have to like so next step is your the formula. So if the formula for the one step process is we like sigma. So I'm writing the formula for the same. So it will be so summation of fx square. One second. It will be like summation f. So summation of f into summation of fx square or I will show you the photograph. So the formula will be like um, it will be summation of fx square divided by summation of f minus of summation of fx divided by summation of f whole square and the under the root. So that becomes the formula for like the mean. So how we can write that? We can write it like this: summation of fx square divided by summation of f. Summation of fx square divided by summation of f minus of summation of fx, summation of fx divided by summation of f. So that becomes the formula, one step process of the calculation of the mean. So summation fx square divided by summation f minus summation fx divided by summation f. So in that case, you first have to calculate the midpoint of the data. So if we are calculating the midpoint, so m here is like 5 and 10. The midpoint is 2.5. So midpoint becomes 2.5, then 12.5. Sorry, 5 to 10. 5 to 10 is 7.5. The midpoint is 7.5. 10 to 15 is 12.5. Then you have 17.5. Then 22.5. 27.5 and 32.5. So this will be your M. Now, where is X? It is now M. So wherever there is X, it is replaced with M now. So first we have to calculate FM square and so on. So now if we calculate M square values, so first we want to find M square. So M square is this value raised to the part 2. So in that way we are calculating the values of M squares and then the summation of M square. So we have